So let's talk about first welfare property and second welfare property. Okay, so let me first talk about first welfare property. Okay, so this is the definition of first welfare property. Okay, so we say that an exchange economy satisfy first welfare property if all its competitive equilibria are Pareto efficient. Okay, is that fine? So, so we say that an economy satisfies first welfare property if all its competitive equilibria are Pareto efficient. Okay, so not even a single competitive equilibrium should be inefficient. Okay, I mean all of its equilibrium should be efficient, and then we say that this economy satisfies first welfare property. So notice that it is a desirable condition. I mean, if an economy satisfies first welfare property, which is a good thing, right? Because you have chosen a market mechanism to allocate stuff. So competitive equilibrium is a market mechanism through which you are trying to allocate stuff, and you would want whatever outcome you are going to get through the markets. That should be desirable, right? I mean, what do you mean by desirable? In our case, desirable means it should be Pareto efficient. Okay, so it's a good thing. I mean, if an economy satisfies first welfare property, it's a good thing. Is that okay? Okay, so we would like to check. So obviously, the way you want to check whether an economy satisfies first welfare property or not is by simply finding all the competitive equilibrium allocations and checking if it's a subset of the set of Pareto efficient allocations or not. That's all that you need to do. Is that clear? Okay, so the question is, isn't this always true that that first welfare property holds for all economies? And let's check that. Okay, so let me give you an example. Okay, so consider a pure exchange economy. So suppose there are two consumers. Okay, consumer one's utility function is x1 plus y1. Okay, and consumer two is I mean, you can just think of consumer 2 as someone who doesn't really care how much he consumes. Okay, his utility is always 0. Okay, is that fine? So utility of 1 is x1 plus y1, utility of 2 is 0. Suppose the endowment is 5555. Okay, fine. Now why don't you tell me what is Pareto efficient in this economy? Can you give me the set of Pareto efficient allocations in this economy? There is only one Pareto efficient allocation, which is in which individual one consumes everything. That's right, very good. Okay, so set of Pareto efficient allocations is a singleton set, okay, which consists of this allocation that you just mentioned, 10 comma 10, 0 comma 0. Okay, is that fine? Now let us find all the competitive equilibrium allocations in this. Okay, tell me, so can you tell me what is the competitive equilibrium price in this case? Okay, just look at this. So let us try, price ratio greater than 1. Okay, of course, we can easily rule out 0 prices. We can straight away rule out 0 prices because, if any of the price is 0, then consumer 1 will ask for infinite amount of that quantity. Okay, so that will not be possible. Okay, so let's consider the case if Px is greater than Py. Okay, let's consider this case. Okay, so if Px is greater than Py, okay, then the budget line will have slope Px by Py, which is going to be a steeper line compared to the line of slope 1. So this is a line of slope 1. So you'll get a steeper line like this, right? So notice that if you have a steeper line, let's consider a line like this. Now tell me, where will consumer one choose? Which bundle will consumer one choose if this is a budget line? Consumer one will spend all his money on Y, right? Yes or no? Because Y is cheaper. Yes or no? Okay, and that would mean that consumer one will choose this much amount of Y, which is clearly not feasible, right? And there'll be excess demand for Y, so the demand for Y will be more than 10 units. Okay, and therefore this can never be a market clearing price. Okay, and by symmetry, the same argument applies to the case where Px is less than Py. So let's consider this case. In this case, the budget line will look like this. Again, you can see that the consumer will ask for only X, and that point will lie outside the box. So clearly, that cannot be market clearing either. Okay, so Px greater than Py and Py greater than Px, both are ruled out. Okay, so the only possibility left now is the one where Px equals Py, and we can always use the numerator price, let's say 1. Okay, so Px equal to Py equal to 1 is the only possibility left. Okay, in this case, what will happen? In this case, when Px equals Py equals 1, the budget line will coincide with the indifference curve like this. Yes or no? Okay, so consumer in this scenario can choose any point on this line, and consumer 2 can be given whatever is remaining, because consumer 2's utility maximizing choice is everything in the budget set. No matter what he chooses in his budget set, everything is utility maximizing for consumer 2. So consumer 2 is happy with happy consuming the residual. Yes or no? So for example, this allocation is also competitive equilibrium, because consumer 1 is maximizing his utility here, and consumer 2 is also maximizing his utility here. Similarly, this allocation is also competitive equilibrium. In fact, anything on this line is competitive equilibrium. So what is the set of competitive equilibrium allocations in this case? It is, okay, where feasible set is this entire edgeworth box. Okay, and it consists of all these points, where x1 plus y1 equals 10. Is that okay? Okay, and what is the price that supports this? These are the supporting prices. Okay, these are the supporting prices, and these are the competitive equilibrium allocations. Now let me ask you this question: are competitive equilibrium allocations Pareto efficient? No, that's right. Okay, so so it is not necessary that every economy satisfy first welfare property. Okay, it is not necessary that every economy satisfy for first welfare property, but let me give you a sufficient condition. Let me give you a sufficient condition under which the economy will satisfy first welfare property, and that sufficient condition is that all the consumers should have increasing utility functions. Okay, so if all the consumers have increasing utility functions, then first welfare property holds, and we can call this first welfare theorem. This result we can call this first welfare theorem. Is that okay? Is that okay? So notice that in this case, consumer 2 does not have an increasing utility function. Okay, it does not satisfy more is better. Okay, consumer 2's utility function does not satisfy more is better. Okay, so so that led to the failure of first welfare property. Okay, I'm not saying that this is that the utility is increasing is a necessary condition. It is a sufficient condition, because I can always also find examples where utility is not increasing, but still all competitive equilibrium are Pareto efficient. I can also find examples like that. Okay, so this is a sufficient condition, not a necessary condition. Is that okay? Okay, so let's prove it. Okay, so have you understood this so far? Okay, so by the way, if I replace this by 0, can you tell me now what are the Pareto efficient allocations in this case? The entire feasible set, right? All allocations are Pareto efficient. So clearly, in this case, first welfare property holds, even though utilities are not increasing. But in this case, first welfare property holds, because whatever the competitive equilibrium is going to be in the feasible set, right? And every feasible allocation here is Pareto efficient. So even without finding the competitive equilibrium allocations, you can straight away say that because all feasible allocations are Pareto efficient, therefore first welfare property holds. Is that okay? Is that okay? In the previous economy, it wasn't satisfied, but in this economy, it is satisfied. Okay.